Since the last video I've been working on the profile for the yoke, so I've machined both of the rear faces. I've also tidied up the clamp part for the stem, still needs a bit more work to make it look pretty. I've also machined off the proper dimensions for the shoulders for the fork leg clamps. In terms of the next operation, I need to think about machining the recess for the display, the motoscope.pro display. I intend to put a recess in the top for the motoscope to sit in. It does involve machining this arc, and to do that I'm going to need to use the rotary table, but also put a point in the bottom of the yoke to be able to accurately locate the yoke onto the rotary table in such a way that I can use an end mill to cut that diameter. What I'll do now is I'll clamp the yoke top down onto the table and then drill a pivot point, effectively the bottom of the yoke. Hopefully it'll all make sense as I go along and show you how I'm going to use the rotary table to be able to mill that curve. I've now drilled the pivot hole to allow me to centralize the yoke in the rotary table to cut the curve, the arc, for the Motoscope.pro. You can see the curved parts of it there. I've also drilled the holes through and into a recess for the cable entry and for the two retaining screws for the Motoscope.pro. And to give some context on that, you can see the cable entry in the middle and the two M3 holes for the retaining screws. So what I'm going to do first is I'm actually going to use a slot drill to cut a slot parallel to the front face, which will effectively be the back edge of the Motoscope.pro. I'm going to go down, I think it's 10mm on my design, I need to check. So I will mill using a slot drill, which would be 16mm across, because those curves at the end, those inner curves, are an 8mm radius, so 16mm diameter. With that slot then cut across, I'll probably remove some of the other excess material to make the cutting of the curve less onerous when it comes to it. Okay, so as pretty much always, I've got the reference point programmed into the DRO for the far right, which will be the front right hand corner of the yoke when it's in position. If I've done my calculations right, I should be running a slot from 24.5mm back from the front, so 24.5mm towards me, and then from 71.25 to 163.75 on the x-axis. All that remains is to cut the curve for the forward part of the motoscope, so effectively that arc there. To do that, I'll be using the rotary table. To machine that arc successfully, which is a radius of 58mm from a point round about the centre of the yoke, I need to ensure that that centre point is directly above the centre of the rotary table. And then ultimately I need to ensure that the rotary table is centred directly below the quill, and then I can offset it by the relevant amount to get that 58mm radius. To centre the yoke on the rotary table, what I've done is on the rear side, or the bottom, is I've milled a hole. It's a 14mm diameter hole, and that is the centre point for that radius. To get the hole, the 14mm hole, centred directly on the rotary table is actually quite an easy task to do. The centre of the rotary table has a 1 Morse taper spindle. So what I've done is turned a little adapter which has got 14mm diameter, which will fit in the hole that I've drilled into the base of the yoke. The other end of that little adapter is 12mm, which I can now fit into a 12mm collet, a 1MT collet, which will then fit down into the spindle for the rotary table, thus ensuring that this hole is centered directly onto the rotary table. My challenge with the rotary table though is mine is quite small. It's only a 6-inch table, and I'm not going to be able to clamp the yoke onto the table as it is. So to enable me to clamp the yoke to the rotary table, I've machined a plate. The plate will fit onto the rotary table. It has 3 holes, 5 holes in fact. One in the centre, which is for the centre of the rotary table. 2 others which will allow me to clamp 2 T-nuts in 2 of the slots, and the other 2 are what I will use to hold the yoke itself against this plate. The slight downside is that this will not be perfectly flat, so it will introduce a level of error, but I think it will be insignificant and not enough for me to worry about. What I now need to do is set the height of the head on the milling machine and then centre the table directly below the quill. Okay, that's good. What I'll now do is reset the DRO, X and Y both to 0. What I've done now is I've kept the Y-axis locked, so in terms of front to back, the centre of the quill is directly above the centre line for that radius, but I've moved the table left to right, or I've moved it to the right by the radius of the arc minus the radius of the slot drill. So it's a 58mm radius for the arc, and I've got a 16mm slot drill, so I've offset the X-axis by 50mm to the right. Before I took the full depth cut, I did a little check. I touched off on the far side, but as I then rotated the table around, I wasn't getting a corresponding cut. In fact, I wasn't getting any contact at all on this side, indicating that the whole yoke is slightly tilted. What I've done is I've packed some shim under this side. It's a bit crude, but hopefully it will even me out enough. Not quite fitting. I'm going to take that radius out 0.1 of a millimetre. That fits nicely. Nice little bit of movement, so it's not wedged in there. Quite happy with that.